Hello everyone, welcome back. Let's wait for 5 more minutes, then we'll start. Okay, so until now we have seen basic Python. We have built an application using Python Streamlit. Today we'll be learning about Python libraries and seeing some of the important Python libraries. Okay, so let's first see what Python libraries actually are. So, libraries is basically a pre-written code or modules or functions that we can use again and again. Instead of writing complex codes from scratch, we can reuse the codes that are already present in the libraries. We can just import the libraries and we can use the codes from there. Codes, functions, modules, whatever is present in the library, we can use all of that. So basically, library is like a reusable system where codes are present and we can, instead of writing the code from scratch, we can use them. Okay, it's like a calculator. Okay, in calculator we feed some numbers and just press on the add or subtract or multiplication button, and then we get the result. Now we are not doing it ourselves. We are just using whatever function and whatever whatever tool the calculator is providing us. Same our Python libraries. We can use whatever functions, modules, or codes the libraries are providing by downloading and importing the libraries. Okay, so the first library we'll see today is NumPy. NumPy, basically the NumPy name stands for numerical Python. It is the base library, and it basically helps us in mathematical operations and arrays. It provides high dimensional arrays to us, and we can use those arrays, and we can perform mathematical operations on those arrays. Like here, there's an example. Let's open Collab and see how this example runs. Okay, so this is the example of NumPy. Here we imported NumPy as NP so that we don't have to write NumPy again and again. We shortened it. Now here we took a variable, and we called array function from NP library, NP as in NumPy library, and then we made a array 10, 20, 30, 40, and basically it's a 1D array. 1D array means there is only one row, there is no column, and 2D array means there is a row and there is a column. So this is a 1D array. Now for result, first we printed the array, this array, and then in the result we took a variable result. We multiplied all the array with 2 and then printed the result. Let's see the output. Okay, like this. So first the array is simply printed here, and then the array is multiplied by 2 and printed, like 10 into 2 20, 20 into 2 40, 30 into 2 60, and similarly 40 into 2 80. If you have any doubts, please write it in the comment section. I'll answer those. Okay, so the main functions of this library is to do fast numerical calculations, perform mathematical operations, and basically this library serves as base library, and it can be integrated by other high level libraries to perform our calculations, or whatever we want to do. We can integrate other libraries with this library. Okay, the second library is Pandas. Now, Pandas is basically used for data manipulation. What is data manipulation? Like if we want to change some data, or we want to add or remove some data, it all comes under data manipulation, and it is all done by Pandas. So in Pandas we have mainly two data structures. What are those? The first one is series and the second one is data frame. The series is like 1D array. the one we studied here, like this 1D array. This is a series, and data frame is like a table where we have rows and columns. That is known as data frame. And the functions of this library is basically it is used to handle big data and data with rows and columns, that is known as data frames. It is used for data cleaning, pre-processing, like if we want to merge a data, join a data, or if I want to add some data or delete some data, like anything I want to do with the data, I can do with this. Is it clear, pandas? Okay, we have a doubt. Harika, yes, without using the NumPy library, we can also write the same program. We did that in the last class. To do that, we simply use list. Let me show you just a second. Okay, so if you want to do the same thing without using the NumPy library, we can use like this. Let's take this one only, like this. Is it clear? Okay, if it's clear, let's move on to the next program. Okay, let's see this now. The Okay, let's see this pandas example. So first we imported pandas as PD. So we don't have to write pandas again and again. Now we took a variable data. In data we stored a data frame. Now what was data frame again? Data frame was like data structure like table where we have rows and columns. Now in data we stored name. The name is Ali and Bob. And second, we stored their ages 25 and 30. Next, we stored what city they live in, New York and Los Angeles. Now, we took one more variable, df. Now, in df, first we called pd. Then we put dot is for if we want to call a function from PD. PD as in pandas library. Now from pandas library I want to call data frame so that I can convert this whole thing into a data frame like this. Now the original data frame is first the name Ali and Bob, now age 25, 30, and city NY and LA. So this is the whole DF that is printed. Now if I want to print only one single column, suppose I want to print only age, so I can print age. How? First, we took a variable ages. Now from the df, from what is df? In df we stored all the data frame. From df we picked age and then simply print the age. What is okay? So what is this? Basically, this is the heading. If I want to give, I can give, or simply I can take. I can print without this. I can simply print without this also, like this. Now, this is the first output, and second 25 and 30. And this line is for what column we printed age and the data type in it was int. Okay, if it's clear, let's move on to the next one. Okay, so Pandas is basically for data manipulation. The third is Matplotlib. So Matplotlib is basically used for visualization. Mainly, like if you want to visualize something, like I want to make a bar chart or pie chart or any type of plot. If I want to make, I can make it from Matplotlib. It basically generates 2D plots like line plot or scatter chart or bar graph or histogram, anything like that. That is 2D. And in that, we can customize the labels, titles, and legends of the graphs. And basically, it supports various types of output formats. Like we can print the output in PNG, JPG, or we can download the output in PDF any way we want. So basically, this is a library that helps in visualizing the code or visualizing whatever I give it. Let's see an example. Now look at this. First, I imported a Matplotlib library as PLT. Then from in X variable I put XYZ and in Y variable I put ABC. Now I called PLT as in the library, and I called the function plot. What does plot do? Basically, it plots the x and y on a graph. Then I put the labels. So the x label I gave is x values and the y label I gave is y values. And the title of the graph I gave is line plot. This is the title, and yeah, this is the a y label I gave, and this is the x label I gave. And you can see on x-axis XYZ and on y-axis ABC, and it is plotting a line chart between them. Okay, is it clear? Is Matplotlib clear? Okay. If it's clear, let's move on to our next library. So the next library is Seaborn. It is another visualization library. Now, Seaborn is used to visualize high level statistical plots. Like if I want to visualize a heat map, or if I did a coding ML and did a coding and I made a ML model and I need to visualize the results. For that I can't use Matplotlib. I have to use Seaborn because I need high level plots like time series plot or regression plot, etc. Now Seaborn is like a add-on on Matplotlib. Matplotlib is the basic library for visualization, and if you are using visualization, you have to use Matplotlib. And Seaborn is basically a add-on on that. It uses Matplotlib as its base library to perform any visualization activity. Okay, let's see the example. Okay, let's see the example of Seaborn. So first we imported Seaborn as SNS, then we imported Matplotlib as PLT, then took two variables, categories and values. In categories A, B, C, I took a list and the values I took are A, B and C. And in values I took the values of this category 10 for A, 20 for B and 15 for C. Now I use the Seaborn library and called bar plot. Now in x-axis I gave categories and in y-axis I gave values. Now I use the PLT as in matplot library to show whatever visualization I did. I am showing it with matplot library show function like this. So in A we gave 10, B 20 and C 15. So in A we are getting 10, in B we are getting 20 and in C we are getting 15. Now did you notice that when we ran the program I only gave 10, 20 and 15, but in this it started from 0 and scaled it to 20. Now what is happening? First 10, 20 and 15, so it is making it is basically scaling the values and making it so that the user can easily read and so that it can scale up to the whatever values we gave. Whatever values we give here, it is only the reference. Now the raw values, the raw points, the system takes reference from that and then scales the raw values to the actual values in the x or y scale. Mukesh, data science or data analysis, you can use Google Colab or Jupyter, it doesn't matter, but I'm using Google Colab because Colab gives better features. Like if you want to use Jupyter, you can use Jupyter, but I would say that Colab is better because it comes with AI facility. You can use the AI facility like this one. This is Gemini. If I ask Gemini to make a code, it will give the code and it will run it here. Like if I If I write a program, now, now see, here I am not using a bracket. Here I am not using the end square bracket. But let's assume that I don't know that what is the issue. Now I run this and error is coming. It is this was never closed, but I still don't understand the error. So I can simply click on explain error and it will generate whatever, it will analyze the error and generate the correct code. Now accept and run. Now look, my error is solved. So it gives AI capabilities and basically it gives much more installed libraries. So it is, in my opinion, better. But if you want to make bigger projects or scalable projects, you can either use Jupyter or you can use VS Code or PyCharm. Okay, if it's clear, let's move on to the next one. Okay, so the next library is the machine learning library, Scikit-learn. So it is basically used in machine learning and basically it is the primary and base library for machine learning algorithms. It can be used in anything related to machine learning, like classification, regression, or clustering. Like what is classification? First, let's see that. So classification is basically when we have many values and when we have to categorize those values. Like if I, for example, if I have to identify, just a second. Okay, if I have to identify spam emails, so either the emails will be spam or it will not be spam. Only two categories I have. So it's classifying. Either it's spam or it is not spam. Now diagnosing a disease. Now from all the diseases, it can be only it can be a disease or maybe one or two diseases, but the categories are same. Like it cannot predict a disease that is new, or maybe it can only predict from a realm of diseases. Like I only fed it that it can predict either it is fever or it is cough. So it can only predict from those two. Or maybe classifying images of animals. Now images, how in animals, maybe the image of the animal is lion, so it will predict that yeah, this is lion, it is classifying that image into lion. Now regression, what is regression? Basically when we are predicting continuous values, numerical values. For example, if we are forecasting weather updates or we are forecasting house prices or anything, like the weather update. So we all see maybe tomorrow will be 27 degrees or 18 degrees. What is that? What that is prediction. We are predicting the values. Now clustering. What is clustering? Basically, we are grouping the similar data points. Like for a Mumbai, like for example, a movie came and some people didn't like the movie and some people liked the movie. So we are grouping the people who liked the movie and we are grouping the people who didn't like the movie. That is clustering. Is it clear? Is classification, regression, and clustering clear? If you have any doubt, please write it in the chat section. Basically, Skitlearn helps in all these three. Anything related to machine learning, Skitlearn helps with that. And uh, we'll see an example of Skitlearn in the next class. Okay, if there's no doubt, let's move on to our next library. Okay, so the next library is SciPy. Basically, it stands for Scientific Python. Basically, it is an add-on on NumPy library. So basically uses NumPy arrays as its structure base, core data structure, and the NumPy handles basic numerical operations, and SciPy, if we have to do anything advanced, then SciPy does it. Basically, this Seaborn was an add-on on Matplotlib. Similarly, SciPy is an add-on on NumPy. So, what does NumPy SciPy library does? It helps in linear algebra or differential equations, integration, differentiation, determinants, anything matrix related, linear algebra. It helps with all of that, all of the advanced mathematical or scientific functions. Okay, let's see an example for this. So, what are we doing here? We are basically importing NumPy first as NP, and then we are importing. Okay, so SciPy is a library, and from SciPy we are importing linear algebra. So LINALG, basically it stands for linear algebra. In linear algebra, basically all the matrix related stuff, determinants, and integration, all of that comes under this one. So now we are taking a variable a, and in that variable we are making a array using NumPy library. So this is a 2D array. 2D array means when we have rows and columns. Like, okay, first let's print this one. Okay, so this is the array. This has rows and columns. So 1, 2, and 3 and 4. Now, from this, we took another variable determinant, and using this library, we are borrowing a function det for determinant, and uh, we are taking the determinant of a and then printing the determinant, and the answer is minus 2.0. Is it clear? Okay, if it's clear, let's move on to the next one. I hope you all know. Okay. Okay, so minus 2.0, it comes with this one. So the formula of determinant is basically A into D. A into D means that this 1 is A, 2 is B, 3 is C, and 4 is D. So A into D, as in 4 into 1, 4, and then B into C. So 2 into 3, 6. Now 4 minus 6, that is minus 2. That's how determinant is calculated. Okay, if it's clear and there's no doubt, let's move on to the next one. Okay, so the next one is TensorFlow and PyTorch. So TensorFlow and PyTorch are deep learning libraries. Basically, it helps in developing models and train models from deep learning, and the libraries that we use are TensorFlow and PyTorch. So TensorFlow is basically developed by Google. It is basically used for large scale machine learning and deep learning operations, and it is fully scalable. Basically, if we have to do high numerical operation or high computation like in machine learning or deep learning tasks, it is the library that is preferred, and it is used in image recognition, natural language processing, and basically it is used where we are developing a model that we have to use in production and we have to scale that, then we'll use TensorFlow. And PyTorch is also a library, deep learning library. It was created by Meta, and basically it is used for prototypes and academic researches. So if we have to build something that we are researching on or for experimentation purposes, then we use PyTorch. It, basically, this is used in for academic innovation or research prototyping on things like that. So if we have to build some, both are deep learning libraries, but we have to build something that is scalable and production. For production, then we'll use TensorFlow, and if we are doing some research or for experimentation purposes, then we use PyTorch. Okay, I hope this is clear. What is TensorFlow and PyTorch? If it's clear, the next one is, let's let's recap what we learned and when to use what library. Like if I have to use now, if I want to do some numerical operations, and if I want to do something with array, then I'll use NumPy. If I have to do something related to data and data manipulation, like pre-processing or cleaning the data, then I'll use Pandas. If I have to visualize something and create plots and charts, then I'll use Matplotlib and Seaborn. If I want to do something related to machine learning like classification, regression, clustering, then I'll use Scikit-learn, machine learning library. If I have to do some scientific calculation or like high mathematical calculation, then I'll use SciPy, which is basically an add-on on NumPy. And TensorFlow and PyTorch are used when we have to do something related to deep learning, and uh, basically when we have to train high neural network model, or we have to train bigger models and you use images and videos, then we use machine deep learning, that is TensorFlow and PyTorch. Okay, is it clear? If Do you guys have any questions related to anything, or if you want me to explain a certain library again? If you guys have any question, please write them in the comment section and I'll answer those. Or if you want me to explain a certain library or code again. Okay, I don't see any questions in the chat section. If you have no questions, okay, let's lastly see recap the codes again. First, we did the NumPy code. We learned what is 1D and 2D array and how we can use NumPy to create arrays and do mathematical operations on that. Then we used Pandas to create a data frame and separate a column and print that. Next, we use the Matplotlib library to visualize a plot. Next, we use Seaborn library to visualize a plot. That is an add-on on Matplotlib. Next, we saw how SciPy is used, how it uses NumPy as the base, and how we can use SciPy. Then we saw how we can use SciPy. Okay, so do you guys have no questions? If you have no questions, we'll conclude today's class. Okay, if you don't have any questions, let's conclude the class.